Donnell. Isaac.
Here.
Ishi. Madison.
Here.
Kayla. John.
Here.
Alex Garcia. Jasmine Godinez.
Here.
Matthew.
Here.
Brandon.
Here.
Morella. Jeshua.
Here.
Annika.
Here.
Eric.
Here.
Gracie.
Here.
Carlos.
Here.
Jose.
Here.
Ethan.
Here.
Natalia.
Here.
Jaylene.
Here.
Giovanna.
Here.
Taylor.
Here.
Jay. Gianna.
Here.
Jacob.
Here.
Roberto.
Here.
And Ariana.
Here.
Okay, very good. I went so fast in that roll. Was that fast? You guys got to be ready for it. You got to be ready to say here. But there's a lot of people absent. So weird that there's a lot of people absent. Here's who I have absent. Donnell Abier, Isaac Aquino, Ishi Blanco, Kayla Bradley, John Chavola, Alex Garcia, Morella Hanone, Jose Orozco, Giovanna Ruiz, and Jay Singh. Let's start from the beginning. Donnell. Isaac.
I'm here.
Was that Isaac? It sounded muffled.
Yeah, that's me.
Okay. Ishi.
I'm here.
Kayla.
Here.
John.
Here.
Alex Garcia. Morella.
Here.
Jose Orozco.
Here.
Giovanna.
Here.
Jay.
Here.
Okay. So now I have Donnell and Alex Garcia absent. Donnell Abier and Alex Garcia are absent. Are any of those people here? Donnell or Abier? Donnell's absent. Abier's absent. Okay. All right, cool. How was the, wait, today is Wednesday, right? Okay, so we did two things on the Delta Math. Finished the Delta Math today. Where am I? There, can you guys see me? 26 people here. Do you guys have any questions from the assignments that we, oh, look, my camera's not even, what happened with my camera? Oh, tech is the worst. The worst. Whiteboard, open jam. What's the worst? Technology. I'm telling you, all those movies are true about technology. The Terminator and the Matrix, right? They're just going to turn on us. I'm telling you. I mean, those are not fictional movies. Those are documentaries. Oh, wait, I just messed with my microphone. I mean to do that. Okay, can you see me now? Jay, can you see me?
Yeah, I can.
I can't see you, man. Oh, there you are. Very handsome. You're looking very handsome today. Thank you, Jay. I appreciate it. Okay. All right. How do we do this? So we talked about polar coordinates and rectangular coordinates, right? How to graph imaginary number or complex numbers. We talked about that. We talked about going from polar form to rectangular form. Now we're going to go from rectangular form to polar form. Okay, so let's get started. Let's see I like accidentally opened up in the wrong window, so hopefully my presentation will show. If you can't see my presentation, let me know. And oh wait a minute. Wait a minute. Make sure my document camera is working. Oh, by the way, get your unit circles out. That helps. The unit circles help a little bit here, or they can actually help a lot if you use them right. Have your unit circles out. Donnell, are you there yet? I didn't even save attendance. You guys see me taking your attendance? Okay, boom. And let's go to Delta Math. Make sure you have your unit circles out. Look at this. I have one right here, all set to go. I also have one printed up. You can use either a printed one or a virtual one. Oh no. Lucas is dying. Oh, there he's better. Okay. I was worried there. I thought Lucas was sick. All right. So I'm just going to do a problem. You guys can take a look on how to do it. Oh, look, they have the answer here. I can't go back. Let's go to my teacher account. Look at period 3. And okay, let's look at the first one. Okay, this is very intuitive. What I mean by that, where are you guys? What I mean by that, you guys can see me looking at you. What I mean by intuitive is if you think about it, you don't have to memorize any formulas or stuff like that, but if you think about how stuff works as far as right triangles and trigonometry and SOHCAHTOA and angle measurement, if you think about everything that you know, you can solve this. You just have to use what you know, okay? You have to put it all together. That's what's great about math, and that's also what's also hard about math. You have all the stuff that you know, you just kind of put it together. But if you don't know the stuff very well, it makes it much harder to do. So anyway, let's use our intuition to solve these. So we're going to convert rectangular coordinates 2 root 2, comma 2 root 2 into polar form. Express the angle used in radians. That means we use the pi over the intervals 0, theta, 2 pi. This is nice. You don't really have to, this, okay. Let me explain what this means. If it doesn't make sense to you, it's okay, because I'll just simplify it after I explain it. What this means is we just go around the circle once. We can have multiple angles going round and around and around and around, right? Which we talked about before. But this means we just only need to go over it once. So basically, what does that mean to you? What does that mean to you, Lucas? That's right. What that means to you is it means you only need one answer. It just makes it easier for you. That 0 to 2 pi. Okay, so we are going from rectangular form to polar form is the topic. Or rectangular coordinates to polar form, or rectangular coordinates to polar coordinates, whatever you want to call it. And we have here, we're going from 2 root 2, comma, wait, I don't like how I wrote that. I know I'm not presenting. I'm going to 2 root 2, comma, 2 root 2. I know you're not seeing what I'm writing here, but here it is, okay? So I kind of don't like the way I wrote it here, so I just cross that out. Sorry about that sloppiness. Okay, so we're going to use our intuition. We're going from, your topic is rectangular form to polar form, okay? So we're going from 2 root 2 to 2 root 2. What the heck is 2 root 2? What the heck is that number? I have no idea. It doesn't matter. We're going to use our intuition. And what I mean by that, let's just draw a picture. So draw the picture with me. It doesn't have to be accurate. It's not going to be to scale. It's going to be more of a sketch. So 2 root 2 over 2 root 2 is going to be, let's say it's somewhere over here. And I have that point. I'm going to draw my radius. Remember, this is called the radius. And then that's where we're at. Now, this is X. This is Y. So let's draw our coordinates here. If I was to go here, that means at this point right here, X is 2 root 2, right? That's my 2 root 2. And then I went up here, 2 root 2. So I went over 2 root 2 and I went up 2 root 2. Okay, you guys see that picture there? Does that make sense? Hopefully it makes sense. Any questions so far? So we got what we got. Annika, how are we doing? Am I making sense so far? Are you with me?
Yeah,
You sure?
yeah.
Okay, I'm here for you if you're not. Let me know. Ask questions. How about you, Brandon? How are we doing?
Good.
Okay, cool. You understanding this, Brandon?
Yeah.
Okay, cool. Now, rectangular form is x, y. We also do real numbers and imaginary numbers, right? We've been talking about that. Polar form is r comma theta. Okay? Is r comma theta. So, well, let's go like this for class participation. Eric K., what does r stand for?
Did you call me?
Yeah? Just want to know what r means.
Oh, radian.
No. Try again.
Oh, radius, radius.
Radius. Very good. I guess it's close. Radians, radius. And then what does theta mean? Ethan, tell me what theta means.
It's
Or what is theta? Just I don't know. If I was a sixth grader or seventh grader and they said, "Hey, Ethan, what's theta?" What would you tell that sixth grader or seventh grader?
Is it like the degree of the angle?
Yes, the angle measurement. And degrees or radians, which we're going to use radians for theta. Very good. That's all I need to know. So what we need to figure out here is we need to figure out what is this r and what is this theta there. Got it? Okay, that's what we want to do. Okay, so we're going to use our intuition to figure that out. And we're going to use our intuition by drawing another triangle. So I'm going to make a little triangle here. And I want you to draw one too. We're going to draw it big so that we can see. So I have that triangle. See, it makes a triangle. It makes a perfectly awesome right triangle. And I'm going to draw one right here. Using everything we know everything that I'm going to show you is not going to be new. We're just going to be putting it together in a new way, like I keep saying. So here is my triangle. Now, with my right triangle, it's going to be a right triangle. With my right triangle, I have here, this is 2 square root 2, and this is 2 square root 2. We need to solve for r and solve for theta. Okay, let's first solve for r, okay? You know how to solve for r right now. You know, in fact, I'll tell you what. You knew how to solve for r in 7th grade. I'm sure most of you knew how to solve for r in 7th grade. Okay, if I was in 7th grade, if you're in 7th grade and I said, hey, solve for r, you would solve for r, but I would not say r. If I was a 7th grade teacher, I would call it the hypotenuse, right? So, you're in your 7th grade class and I'm asking you, right? Madison, how would you solve for r?
Would you use the form for hypotenuse?
Okay, what do you mean by that? Because it is the hypotenuse.
A squared plus b squared root.
Yes, yes, yes. That's what I'm talking about. That's what you want to do right there. Do that. It's the Pythagorean theorem. And in 7th grade, I think, did you solve that in 7th grade, Madison? Is that when you learned the Pythagorean theorem?
I think so.
I've never taught. I taught 7th grade once as a student teacher a long time ago. A squared plus b squared equals c squared. Let's substitute our numbers. Follow along with me. 2 root 2 squared plus, right? A squared, b squared. It doesn't matter which one's what. 2 root 2 squared equals c squared. Great. I got a question. What is 2 times the square root of 2 squared? Let's go with Matthew. Can you do that real quick in your head?
Wait, do what?
2 root 2 squared. What is that equal to? Let me know if you need some help there, Matthew.
Yeah. Hold on.
I can't hear you. Wait, either my volume's down or you have a very soft voice. Okay, I turned my volume up. Okay.
Wait, can you hear me?
I can hear you. My volume was down.
Okay. Root 2?
Matthew, I'm going to give you a hint here, okay? Are you with me?
Yeah.
2 root 2 squared is like saying 2 squared times root 2 squared.
Right.
What's 2 squared?
Wait, can you hear me?
Matt,
Wait, can you hear me?
I did not hear a thing that you said. What's 2 squared?
4?
Yeah, very good. Now, what's root 2 squared?
2?
Yes. You get rid, it just cancels out the square root. 4 times 2 is equal to what?
8.
There you go. That's all you got to do. You all know how to do that, right? So this is 8 plus 8 equals c squared, or 16 equals c squared, square root c equals 4. Or how do you say 4 in Spanish? I think it's corazón. So anyway, my radius is equal to 4. Corazón. So we got, guess what? I'll leave it here for a second so you guys can type, write it up, write down everything that we did. 2 root 2 squared plus 2 root 2 squared equals r squared. 2 root 2 squared is 8. 2 root 2 squared is 8. 8 plus 8 is 16. Take the square root of 16, we get corazón. What happens if what does this do? If I hit that, what does that do? Recording? What does this do? Annotating? Whoa! Oh shoot, now can I erase it? Oh no. What the heck? How do I erase it now? What did I just do? Oh, I did it. Okay. All right. So let's get here. Let's figure out. Now we just need. So what do we do? R equals 4. Whoops. Oh, this. Okay. I'm like messing with this. I don't. Oh no. Okay. R equals 4. So we have this right here of R equals. We have the R. Now we just need the theta. Do we know how to figure out theta? Using our intuition. We do have the tools. You learned this in math too, I believe. We did it in our class too. How do we solve for theta? Okay, that's the question I'm going to ask you. How do we solve for theta? I'll give you a hint. It's what Goku says. Roberto, how do you solve for theta?
Well, I'm not sure.
What does Goku say, Roberto?
I don't know.
Do you know who Goku is, Roberto?
Yeah.
Dragon Ball Z, before he shoots the fireball, he says, Sokatoa. Have you ever heard of Sokatoa, Brandon?
Yeah.
Use Sokatoa to solve for theta. What would you use? Sine, cosine, or tangent?
Couldn't you use any of them?
Absolutely. So which one do you want to use?
Sine.
I want to use tangent. I know that's terrible. I said you can use any one. But you can't use any one since we have this. But I'm going to use tangent because those are the sides that are given to me originally. And they're nice numbers that don't have decimals or anything like that. So I'm going to use tangent. So that'll help me with my answer. Again, you can use sine. But let's say tangent of theta is equal to tangent is, should I write SOHCAHTOA down? SOHCAHTOA. Opposite over adjacent. Opposite over adjacent, which doesn't really matter. It is 2 root 2 over 2 root 2, or tan of theta equals 1. So to solve for it, we need to do the inverse tan. So those are going to cancel out. So it's going to be theta is equal to the inverse tan of 1. So on your calculator, you're going to do the inverse tan, which is going to be, doing your calculator, it'll be 45 degrees. Okay, so guess what? Now we have theta. Let me get that up there so you can see it. We have theta now. So we have our points. However, there's a problem here because of that freaking delta math. Doesn't like that form. What is delta math asking? Using radians. Okay, so we want to use radians. So to convert 45 degrees into radians, 45 degrees into radians, I multiply it by pi over 180 degrees. That way the degrees goes below, so the degrees cancels out. 45 pi over 180, and then we just reduce the fraction. Both top and bottom are divisible by 45. 45 divided by 45 is pi. 180 divided by 45 is 4. So there is my theta, 4 comma pi over 4. And that's all you got to do. Circle it in red so you can know that the answer is in red. That's our final answer. Are there any questions? Intuition. Use a Pythagorean theorem to find the radius. Use inverse tan to find theta. Because I'll give you the coordinates. You always use the inverse tan to find theta. Because you can just use the coordinates that are given. You don't even need to look at them. You don't need to draw the triangle. That's it. Now, there's a couple curveballs they're going to throw at you. So let's see if we make sure we enter this right. Make sure you do a comma. You do a 4. I'm sorry, you do a parentheses. You do a 4. Then you do a comma. Then you hit the little pi. Hit the division sign. I hit the little slash under the question mark. And then 4. And then that's it. That should work. Okay, that's how you want to enter your answer. Make sure you enter it correctly. It's not too picky, but it's kind of picky. Are you sure this is what you want to submit this as your answer? Yes, and boom. Okay, so look how they did it. 2 root 2, 2 root 2. You plot it. You make the triangle. You use the Pythagorean theorem to find the hypotenuse, which is what we did. A squared plus B squared equals C squared. They just take the square root there to find it. before. Then you use inverse tan to get the reference angle. You get pi over 4, and that's all you got to do. Now, this is really nice because it is in this quadrant here. This is really nice because it is in this quadrant, and it gives me that angle right there. Okay, but if it's in different quadrants, it gets a little bit more tricky. So let's do ones that are in different quadrants. Taylor,
Yeah.
on a scale of 1 to 10, 1 being I don't get it at all, 10 being you can teach it. What's your understanding right now of this?
8.5.
Oh, that's good. Wow, surprise. Okay, I like that. How about you, Morella? What's your understanding?
About an 8 or a 9.
Okay, that's good. Very good. Let's go with Jaylene. What's your understanding?
I'd say about an 8.
Okay, that's good. Hey, you guys, don't lie. If it's lower than an 8, that way I know like how if I'm going too fast or going too slow. Gracie, what's your understanding?
An 8 too.
Okay. All right. Well, hey, good. Okay, I'm trying to find a good problem here for you on. Okay, we'll do this one. Okay, this one's a little bit of a curveball here, but this one's actually easier. Okay, can you guys see what I'm doing here? Okay, now anytime it has a 0, this is actually kind of easier for us. Okay, so the coordinates, but this is also have a negative. This puts in a different quadrant, so it's a little bit more challenging, but not that much. This one, the unit circle, will help us a lot on this. Into the polar form. This one's actually going to be pretty easy. Well, I shouldn't say that. It seems easy to me, but maybe I'm wrong. Okay, so the first thing I'm going to do is I'm going to draw a picture so that we can see what's going on here, because this one's a little bit different. Actually, hang on. Let me write the coordinates down. So we have -4 root 3 comma 0, and we want to put it in radius comma theta. So we got to figure out the radius comma theta, right? So let's draw it on a coordinate plane. Here we go. Okay, now I don't know exactly what -4 root 3 is. It doesn't really matter. I just want to get a picture. So -4 root 3 will be somewhere over here. And then 0 up means it's exactly right there on that point. So there's my coordinates. Let's draw the radius. Now, what do you notice about the radius? The radius is -4 root 3. Half the battle is done. So I got -4 root 3. Boom. Now, from here to here, since it's on there, how many degrees is that? Right, going from there to there? How many degrees is that? What do you think, Isaac?
180.
180 degrees. But we want that in radians. And of course, we can go ahead and do the 180 degrees times pi over 180 degrees. Oh, look at that. This cancels out, and it's equal to pi. And so, -4 root 3 comma pi. That's your answer. That's all you got to do. No triangles, because it doesn't make a triangle. It just kind of goes like over there. Now, the other thing is this answer is all right here in our unit circle, right? You can see this is 180 degrees. There's our pi. Boom. You don't even have to calculate. You can look at your unit circle and do it that way. Okay, that's that one. I'm going to leave it here for like 10 seconds. Are there any questions before I move on? If the x is 0, that means I'd go up here or down here. And it's the same thing. This would be pi over 2, or this would be 3 pi over 2, right? This would be 90 degrees, which is pi over 2. This is 3 pi over 2. But the radius would be somewhere on the x-axis. Anytime it's on the x-axis or the y-axis, that's the radius. Sorry, I just, are there any questions? Ah. I take it no.
Wait, I'm confused. So that one's the answer for that one?
Sorry, yes. Did I not make that clear? The answer is this.
Yeah, I'm putting that on Delta Math and it's telling me it's incorrect.
Yeah, same here.
Oh, because I did do something wrong. I'm glad you guys are entering that. What did I do wrong? Can anyone tell me what I did wrong? It has to do with the radius. Using your intuition. There's one little thing that I did wrong.
It's not the radius?
No, that's the radius. Well, sort of it is. I mean, that's not the thing. Here's a hint. The radius is a length, right? How long is that radius? Can that radius be -4 square root 3?
No,
Why not?
because it has to be a real number.
Well, it can't be well, negative numbers are real, but it can't be negative.
It can't be
So this
real.
should be positive because it's a distance. I apologize for that. So enter that, see what you get. In fact, I'll enter it too. I was going to enter it next. Four root 3. Make sure you get that comma over there. Comma, pi, and that should do it. Hopefully. There you go. See, plot the point. So that can't be negative. So I'm glad. See, there's a little mistake that I made. Don't make that mistake too. All right, let me find another one that is, so let me do one more. That's one little thing that's a little bit different. Okay, let's do this one here. Because I have a negative here, it's going to be in a different, it's going to look kind of weird. So are there any questions before I move on to this one? Okay, this will be the last one that we do. There we go. Okay, 6, -6. What is the radius and what is theta? Put in a coordinate form. Okay, now watch. This one's going to be a little bit different. Now, I'm not drawing this to scale. I just want to draw it so that you can see where things are. So 6, -6 means I go over 6, and I go down 6. This isn't exactly 6, but you get an idea of where this thing is, right? Okay. So let's draw our radius. Okay. Now I'm going to draw a bigger triangle over here. Let's see. Can I fit it? I kind of took up a lot of space with that thing, but. Okay, so this is 6, and remember with distance, there is no negative numbers, but I think we could figure out the radius That's pretty straightforward. 6 squared plus 6 squared equals r squared, which is 36 plus 36 equals r squared. 72 equals r squared, and then we take the square root. R equals the square root of 72. Whoops. So there we go. Now, like, we can break 72 down. You don't need to, but just so that we remember that skill, square root of 72 is equal to 9 times 8. Let's find our prime factors. 9 is 3 and 3. 8 is 2 and 4. 4 is 2 and 2. Those are my prime factors, the square root of 72. Let me know if I'm going too fast. I know this is review. That's why I'm going kind of fast. I'll pause in just a second. Okay. That's the square root of 72 is equal to 2 times 2 times 2 times 3 times 3, based on my prime factors here. Remember, I'm simplifying this fraction here. You don't need to do it with delta math, but it's just a skill that we need to know, remember how to do. Okay, 2 times 2 is 4. Square root of 4 is 2. 3 times 3 is 9. Square root of 9 is 3. So square root of 72 is 6 root 2. R equals 6 root 2. Here we got the radius. 6 root 2. Now we got to find our angle theta. Okay, so here's the thing. This is where theta is going to be. That's what we want to figure out. What is theta? Do I have room to fit that in? I'm going to use tangent. With tangent, these are more like coordinates. So I can go, well, let's do it with positives. Make this, I was going to make this a negative, but I'm just going to go like this. Tan of theta equals 6 over 6, right? You want to get the inverse tan. So we get the inverse tan, right? The inverse, find the angle. So theta equals the inverse tan of 6 over 6 is 1, which we already got that in our calculator, is 45 degrees. We also calculated 45 degrees into radians, which is pi over 4. Okay, now we could have made it negative. It would have made it negative pi over 4. But all we need to know is that this angle here is pi over 4. Now, let's do something here. Let's enter pi over 4 for our answer. 6 root 2 pi over 4. And let's see what happens. Shoot, should I go back? Am I going too fast? Should I shoot? I'll stop that there. I'll leave it there before I enter the answer. Donnell, did you show up yet? Isaac. No? Wait, was Isaac here? You guys are looking at it. Isaac, are you here?
Sorry, I was going to the restroom.
Wait, what?
I was going to the restroom.
Oh, okay. All right. Ishi,
Yeah.
is this making sense so far?
Mm-hmm.
Okay, cool. Jacob, how are we doing? Is this making sense? Scale of 1 to 10. Give it to me, Jacob. How's this going for you?
Probably 7 for me.
Okay. Let me know if you have questions. Okay, so I said 6 root 2 pi over 4. So we said this is pi over 4 right here, right? Right here is pi over 4. Pi over 4 is my angle measure. So let's enter it now. Where are you? 6 root 2. Okay, so we have here, comma, 6 root 2 space, comma, I slash mark 4, and let's see what happens. Are you sure? Wah, wah, wah. Why is my answer incorrect? Does anyone know? Any idea? It says it's incorrect. Let's look at our angles from before. Let's see if I can find my other problems.
Wait, I have a comment / question.
Yeah, go ahead.
Can it be wrong because you put both +6 instead of one negative and one positive?
Well, I could make it, negative pi over 4?
No, because does it affect it that you had to go down -6?
Yes.
So can that be the issue with the triangle or no?
Well, I'll show you that. That's a good point. That's exactly right. Let me see if I can show you why this is wrong and see if that answers your question, Ariana. If you look at these. My angle is from here to here, right? And look at this one. No, that's not. Do I have another one? Where's my other one? No, that one doesn't help. Let's look at this one. My angle goes from here to here. I go this direction. You go counterclockwise. This way, I'm going clockwise. That's not what they recognize. That's not what is the correct answer if you put in your calculator. My angle, actually, it opens up all the way around here. So in this quadrant, it's over this way. How many degrees is this? Okay. So how do I figure that out? Well, if this whole thing is 2 pi, and I'm taking away pi over 4, I can subtract to get this angle right here, right? The whole thing's 2 pi. I take away pi over 4, 2 pi, take away, my favorite singer is 2 pi. Pi over 4, so 2 pi, let's write it here. 2 pi over 1 minus pi over 4, so they're both fractions. 2 pi over 1 minus pi over 4. Let's both have a denominator of 4, which would be 8 pi over 4 minus pi over 4. And then that would be 7 pi over 4. So let's change our answer to 6 root 2, 7 pi over 4. But before I do that, I want to try something on delta math. It's also negative pi over 4. I think that answer would work too. I don't know what delta math will accept. Let me go back because I feel like I went kind of fast there. So to figure this out, I subtracted pi over 4 from 2 pi because the whole place around is 2 pi, but I don't want to go all the way around. I want to go 2 pi minus pi over 4. I got 7 pi over 4. But also this angle is also seen as a negative pi over 4 because I'm taking away pi over 4, which we could have actually figured that out if I made my opposite angle negative in my calculations. That would have given me negative pi over 4. And I'm just curious. I don't even know if I'm wondering if the delta math will accept the negative pi over 4 also. So I know it'll accept 7 pi over 4. So I think both answers may be correct. Let's make this a negative. Or 7 pi over 4. Either one of those. Well, I don't know if the negative will work, but Let's see what happens. Negative pi over 4. Okay, so they want 7 pi over 4. So it has to be 7 pi over 4. So we're going to put here, well, let's make sure. 7 pi over 4, because that's how big the angle is. And we got, yes, there you go. So let's see how they talk about it. Plot the points. 6, negative 6. I got square root of 72. You didn't need to break it down, but I just want to show you that. For the radius, square root of 72, we could have put that. Inverse tan of 6 over 6 is 1, which is pi over 4. And then to figure that out, we take 2 pi minus pi over 4. We get 7 pi over 4, and then there's our answer. So you guys should be able to finish this assignment. But that's it. Are there any questions? Okay. I think we're good. All right, guys. 6 days after today or 7? I can't remember. Anyway, we have a test on Friday. Review the test tomorrow. If you don't have any questions, you can go. Remember, last day for late work is tomorrow. Or Monday. Sorry, Monday. All right. I'll see you guys. Have a good one. Bye, Jasmine. Bye, Carlos. Bye, Eric. Bye, Ethan. Bye, Joshua. Bye, John. Bye, Annika. Bye, Brandon. Bye, Jose. Bye, Ariana. Bye, Roberto. Bye, Ishi.
You done?
Yeah. Oh.
What's your lunch?
Oh. I'll come down and eat. Oh, thank you. My wife just brought me lunch. She's so kind. Okay. All right. Do you guys have anyone have questions that are still here?
I'm confused on the tangent portion of each equation. I don't know why, but like I understand the radiant portion, the radius portion.
Okay.
But the second part, the inverse tangent, I'm confused there.
Okay. I'll do a couple. Let's see. I'll do a couple with you. Let me see if Matthew has a quick question. Then I'll do that with you. Okay, Madison. What's up, Matthew? Hold on. Matthew just left. Okay. Let me stop recording this. Okay.